Fuel cells. When a conventional power plant is viewed, for example, as a whole, as shown in this picture, fuel and air enters the power plant and the product of combustion leaves the unit as shown here, and product of combustion. In addition, heat is transferred to the cooling water. Cooling water, for example, can be a lake or a heat exchanger. And work is done in the form of electrical energy, leaving the power plant as this state. The overall objective of a power plant is to convert the availability of the fuel into work in the most efficient manner. So let me write the overall objective of a power plant is to convert the availability of the fuel into work. In the most efficient manner, taking into consideration cost, space, safety, and environmental concerns. We will ask whether all the equipment in the power plant, such as the steam generator, turbine, maybe we have steam, turbines, condenser, pump is necessary. Fuel cell accomplished also in this type power plant. Is it possible to produce electrical energy from the fuel in a more direct manner? The fuel cell accomplished to use in the power plant. The next picture shows a schematic arrangement of a fuel cell of the ion exchange membrane type. So we have a ion exchange fuel cell, exchange, membrane type. In this fuel cell, hydrogen and oxygen react to form water. Hydrogen react to form water. Hydrogen as enters hydrogen gas at the anode side and is ionized at the surface of the ion exchange membrane. Anode side and ionized from the membrane. As indicated in this picture, the electrons flow through the external circuit to the cathode. Flows to the cathode. And while the positive hydrogen ions migrated through the membrane to the cathode, where both react the oxygen to form water. There is a potential difference between the anode and cathode, and thus there is a flow of electricity potential difference between the anode and cathode. So we have a flow of electricity through a potential difference. This in thermodynamic terms is called work. There may also be transfer of heat between the fuel cell and surrounding. Heat transfer. At the present time, the fuel cell using the fuel cell is usually either hydrogen or a mixture of gaseous hydrocarbons and hydrogen. The oxidizer is usually oxygen. However, current development is directed toward the production of fuel cells that use hydrogen or hydrocarbons, fuel, and air. Although the conventional steam power plant is still in use, large-scale power generator steam and also conventional piston engines and gas turbines are still used in the most transportation power plants. The fuel cells may eventually become a serious competition. The fuel cells is already being used to produce power for the space program and other special applications. Thermodynamics plays a vital role in the analysis, development, and design of all power-producing systems, including reciprocating internal combustion engine and gas turbines. Considerations such as the increase in the efficiency, improved design, optimal operating conditions, reduced environmental pollution, and alternate method of power generation involved. Among other factors, the careful application of fundamentals of thermodynamics. The next, the vapor compression refrigerator is described in the next chapter, in the next section.